Example 1. Okay, we have a mass on a spring. It's displaced vertically, so it's go up and down, allowed to oscillate. So it's a up and down oscillation. The displacement time graph of the resulting simple harmonic motion is shown below. Okay, simple harmonic motion, so it's going to be a sinusoidal graph. Okay, so at first it's at the center, it go up, then come back to the center, then come down, then center again, up, down, up, center, down to the center again. Okay, so this is the displacement time graph for a simple harmonic motion. The amplitude is 0.12 meter. Okay, then the question, so it takes about, so the period is, this is one period, so the period is 2 seconds. This is another period. Okay, second period. Part A, determine the angular frequency for the oscillation of the mass. Angular frequency is omega. We know that the formula for omega is 2 pi over period. Okay, so there we have 2 pi over period, and period is 2 seconds. So equal to pi, but we don't give our answer in terms of pi, we give our answer to 2 or 3 SF. So work it out. It's 3.1 radian per second. Okay, part B, state an equation the formula for displacement x. Okay, in terms of, suppose you say in terms of time. So we want to get a formula for x in terms of time. It's the equation of this graph. Okay, so this is going to be a sine graph. So your x will be 0.12 sine omega t. And omega is, we have just found 3.1. So there will be 0.12, the amplitude, times sine 3.1 t. So that's P part 1. Okay, that's the equation for the simple harmonic motion. Okay, part 2, determine the displacement of the mass at t equals to 0.8 second. Basically, it's just using this equation. We sub in when t equals to 0.8, what is the corresponding x value. Okay, but take note, when you sub in t equals to 0.8, when you do a sine, this is in radian. So make sure your calculator is in a radian mode. So you sub in, okay, you get 0.071 meters. Okay, give to about 2 or 3 SF. Okay, then part C, part 1. Over here, you can either use 3.1 or you can use pi. Okay, doesn't matter. Both will give you around this answer. Okay, part C, part 1. Sketch another graph, but this time it doesn't start from 0. It starts from when the mass is displaced downward by 0.2. So it starts from minus 0.12. Okay? So a graph will start at minus 0.12. It's still a sinusoidal shape. So what does the graph look like if you start at minus 0.12? That would be the lowest point. After that, you go up. So the graph should look like a negative cosine graph. Okay, something. Okay, you look like a negative cosine graph, but with the same amplitude and the same period. Okay, so the graph will look something like this. Okay, it starts at negative 0.12, then goes up. So it's bottom, center, top, center, bottom, center, top. Okay, and the period is still the same, 2 seconds. The period here is from here to here. Amplitude remain the same. Everything else remain the same except the starting point. Okay, then part 2, state an equation for the displacement time graph for the second graph. So they want you the equation for this graph. This is a negative cosine graph. So it will be negative 0.12 cosine omega, same omega, 3.1 t. Okay, so that's the answer for this example.